So today we're going to talk about and demonstrate how glass was beveled probably as long ago as 120 years ago or something, and basically and how it's done today. Here in my shop, there's a lot of things that have kind of gone a different route, but a lot of the machines and the wheels that I have are probably early 1900s. So this is an antique window. Probably, it's hard to say when it was built. I'd say probably late 20s, early 30s. It's rock hard, rock solid. It's made out of zinc. And I've got it here because there's some pieces that need to be replaced. You can see there's holes in some of these areas, and then there's a couple with X's that need to be redone as well. So this is old plate glass, as opposed to new glass. It's float glass, which is a lot harder and bluer green. Let's see here. This is a piece of float glass. It's a little bit greener. It gets a lot bluer green the thicker it gets. That's 3/16. This is probably something like 5/16. So I made a pattern of a piece that has to be done. We're not going to talk about the whole process of how to get this new piece in to the zinc cane. That's another whole story. But for today, we're going to just make it kind of simple and sweet. And we'll work on this piece here, and I'll cut it out on some polished plate glass. The reason why I like to use the old glass, even for new windows, is the glass is a lot softer. It doesn't have the iron content that the new glass has. And they put that in to make this glass more scratch resistant, which is good, but when it comes to grinding and polishing, it's a lot more labor to do it on new glass. So I'm going to show you another antique window before we start cutting some blanks. And here's another one. It's pretty big. And as you can see, there's some broken panes here. This, with the exception of this row of kind of onion shapes, it's all clear textured. That, for the most part, is beveled. These pieces are flat, I just noticed, but this is like an old pinwheel design. This is glue chip glass. So believe it or not, I've got these different odd textures, just for the sake of being thorough. This is a piece of old glue chip glass. It's pretty consistent with what's in that old window. And this also is old. The older glass has kind of got a Vaseline kind of color to it. It's more pale green. Sometimes you'll see it where it's almost yellow. So a lot of times this stuff is scratched up because it's over 100 years old. The beauty of working on this old glass is it's really soft, and you can polish the scratches out in very little time and effort. This is some of the pinwheel pattern. And this stuff was probably made late 1800s. And it was in different thicknesses. It's a lot thinner than the glue chip, but it's thick enough to put a bevel on it without coming down to a knife edge. So this is rolled glass. The glue chip was glass that was probably, they didn't polish it because they were going to glue chip it. So they started out with a glass that was a plate, and then they sandblasted it or ground it with a brick and some emery, and then they put hide glue on it and dried it and then it got so dry that it chipped the glass off. So that's how that's done. This is run through a roller, so this is a repetitive texture that's very consistent. So let's see here. Find, oh yeah. So the old plate glass, this was from an old storefront, and normally I stay away from this kind of glass because it's old and it's been on the street, and window washers have like gotten grime and grit all over it. This looks pretty decent. If I want really pristine old polished plate, I take old mirrors and strip the silvering off and use that instead of the storefront glass. So what I do, and what everybody that in the business does, is they score the glass on the reverse side of where it's going to be beveled. That way, the sharp side that breaks out is on the side you're going to bevel, and you don't end up cutting up your hands. So, a lot of people are under the impression that the old glass is harder to cut. Actually, it's easier to cut because it's softer, and it doesn't get brittle. So, once again, the old glass is a joy to work on. Okay. All right, so that's our blank. I like to mark it so I don't get confused which side to bevel. It's also a good thing to remember, or check rather, how wide the bevel is. It looks like it's about a 1/2 inch wide, so that's what we'll end up with. Okay. So we're going to walk over to a grinding machine. So we're over at the #1 station here, to the rough diamond grinder. This is actually a newer type of process. We're going to go, after this, we're going to review how it was done like a long time ago. These grinding wheels, believe it or not, I got in 1984, and they've been grinding ever since. They started out being about a quarter of an inch thick of diamond, and now it's down to 1/8. Some of the wheels today that they sell are plated diamonds, and they burn out in maybe a month or two. And these are bonded and a 1/4 inch thick, and they're commercially made. So this thing is just an animal. It's been working really hard. So I'm going to turn on the water and turn on the machine. So we're going to go to the next diamond, which is a little bit less abrasive. So it's a finer finish. What we're going to do next is the old-fashioned cast iron lap wheel with either, years ago they probably didn't have silicone carbide, but we do now. They probably had either sand or aluminum oxide. And I need to turn on a phase converter because that's a 3-phase grinder, and I've actually put it on a variable speed drive because for whatever reason I thought the old timers had this thing, just the speed was too high and it was slinging all the abrasive off the wheel. It does sling out, but I think it was slinging it too quickly, so I wasn't grinding that effectively. So I'm going to go turn on the phase converter. So I'm just trying to get it. So I've kind of got it figured out where it drips a little bit of water and it pulls some of the abrasive down. And then the second kind of drip is to give it just some clean water so that it grinds more consistently. So what I have here is a piece of machine beveled glass that was a strip, and it's a common practice for folks in the leaded glass business to take these pre-made strips and then cut them and then have the ends beveled. So both of these pieces of glass will go, we've done our grinding and we're going to go to either the sandstone or the aluminum oxide wheels after this. So at this station, this is a sandstone. This was actually mined out of the earth. And this wheel I've had since the early 80s, and it gets dressed. That's what this device is. It's a dressing plate, and you kind of resurface the wheel so there isn't a dip in it. So this is another three-phase machine, and like that machine, I put it on a speed controller because once again, both these wheels I thought were going too quickly. So we'll fire it up, get it going. There'll be a little drip of water, and I'm going to do the straights. I'm going to do the 3 straights on this, and we'll take it from there. Right here I'm getting the wheel wet, so it's all. One drawback on working on a stone is if you're holding the glass a certain way and you're pressing down a certain way, if everything is just like going a certain way, all of a sudden there'll be a vibration inside the glass and it'll crack. And so you'll kind of hear it coming. There'll be kind of a high-pitched noise. Usually happens on a piece where you've got a lot of time and effort in it, and then all of a sudden it cracks. The alternative to a sandstone wheel is basically like a disc where they have coated it with like a resin that's impregnated with diamond, industrial diamond, and those pads wear out. I'm not trying to be a salesman for sandstones, but Um, that being said, this thing is probably outlasted, I don't know, I would say 2,000 or 3,000, maybe even more, of the resin pads that are rather costly. The thing that's the most important is the maintenance of the wheel, just keeping it true, keeping it at the right level of the glaze that builds up when you are using it. If it gets too glossy, then it's not going to cut and smooth your glass. If it's too coarse, it's probably going to just scratch up your glass a lot. So there was that sound, if you just heard it. It's kind of, there it is again. So as you can see, the inside curves, it's not a possibility here, so we're going to go to the upright wheels, which is what we got started on initially, vertical upright wheels. Okay, we're going to go to the next step. So this is similar to the last machine, but instead of the wheel being horizontal, it's vertical. And actually this is a man-made wheel. The little one over there might be a mined sandstone. And once again, this machine's on like a variable speed controller, because when you're smoothing the glass on a smaller wheel, you want the RPMs to be higher, because the surface speed per minute and all that, you have to be a machinist, but I just go by feel. So this machine has like a little wet sponge on it to keep the wheel wet. If I had my act together, I would have like had a little like tube with some water and have a drip on it. That's the way to go. I'm kind of the cheater here with this wet sponge. That's been my go-to forever on these wheels. So we'll start this up. So this process of smoothing years ago was like referred to as getting the sand out, because the first step was most likely literally ground with sand. So you're trying to get the sand out and end up with a really nice smooth finish ready for the final polish. This is probably, out of all the wheels in the different stations, this is like the money the money wheel here, because if you don't do the smoothing right, it's not going to happen in the next two steps. You're not going to make it like really nice, because if there's a lot of facets and if it's just not right, it's not going to get right on the next step or two. So, but this light's traveled with us. You want to be able to see exactly where the stone is making contact with the glass, so that it's the full width of the bevel, rather than rocking. Because if you start rocking, you won't get a look you want to show anybody. So a lot of people refer to, having the bubble, because it's kind of like a bubble where the glass and the wheel are meeting with the water in between. So we have the machine beveled new glass with two cut ends, and I'm going to finish up here because this has got a little bit of an inside curve, so I'm doing it on the upright. So this is like basically the third step. It's referred to as a cork wheel and pumice. This isn't actually a cork wheel. It's a synthetic wheel, and it outlasts the cork wheel considerably. So, and it doesn't dish out and get all kind of dished out, meaning it's not flat across. You want the wheel nice and true. So this is a rather slow speed. Everything is done wet. So we wet the wheel with just water, and the pumice is applied kind of like in a slurry. You can't see it, it kind of blends in with the wheel. So I guess the topic of where did I learn how to do this, any of this, a lot of it was trial and error. There were probably three guys that I learned different things from, and one of them, well, actually none of them are around anymore. The one I learned the most from was a gentleman called Phil Trask. His dad had a company, and if anybody was my mentor, it would be Phil Trask. So I learned a lot of stuff from him. He never showed me anything really to speak of. None of the, well, one guy did, but Phil, you just watch him work. This was before I actually did this kind of work, and you basically learn just by a few minutes seeing how he worked. The other one was a gentleman called Charlie Viola, and Charlie had a company on the west side of Chicago, and hand beveling company. And the third was actually somebody that actually taught beveling down in Indianapolis, a gentleman by the name of Vince Fox. Quite a few people might have taken his class. I took it because I was like 95% there, but not quite. And within a few hours of taking the class, it became apparent, like, the few little details I didn't have right, and then after a couple hours I realized what I was doing wrong, and the week that the class was for was wasn't really worth the time after that, but I stuck around. So what we're doing here is we're semi-polishing the bevel, and it's getting a lot brighter. Basically, you want to, I haven't been paying as much attention as I should have, but you want to polish the glass in a couple of different, directions, like cross polish it, like this, and then move it over to this. And if you don't keep the wheel charged, you're going to get the glass hot and dry and run the risk of cracking it. So you've got to constantly charge the wheel. There were, back in the old days, where they did this stuff like insanely, like crazy. One guy would be on one wheel, one guy would be on another wheel all day long, all week, all month. And the machine that was this process, the wheels were probably around 30 inches in diameter, and they had a feeding device where a little paddle would charge the wheel automatically, and he'd just go at it, and he wouldn't have to stop and charge the wheel, so he could get a lot done. I actually had one of those machines, but it was way too big, and it just took up so much space. I gave it up. And actually those machines were designed to bevel like front door lights, where they put an 1.5-inch bevel on the glass, and the pieces of glass were like 28 by 72. And yeah, so the whole different world. Now glass like that is all done on a straight line automatic beveler. So we'll give this a rest. Go to this one. So I've got some gloves on, mainly because, well, it would have been a nice idea to have them on for even the other processes. The rubber gloves don't work for me because the rubber attacks my skin, so it's supposed to protect your skin, but it doesn't do that. So the cotton gloves keep the abrasive this is still considered an abrasive. It's pumice off my skin because the pumice and the cerium oxide will dry out your skin considerably. And then regarding health issues and things like that, I mean, like rough grinding, you would have a mask on to keep the ground glass that's airborne out of your lungs. But with just this one or two piece kind of process, since I'm trying to talk at the same time, a mask would be even much more cumbersome. Shot here, and then we'll show the camera how this is coming along. So if you had a really tight inside curve, you would work right on the corner of the wheel to get into a tight curve. Or if you wanted to set up a smaller wheel, you could do it like like this, but more often than not, you don't want to go through all that. You just use the corner, and this does a good job. We don't really have to do it here because this is not a tight inside curve. We can go like this. So, you want to try to catch that here. You can see how much brighter it is as we're moving along. I'll do some, let's see how this one looks. This one actually might look a little kind of fuzzier or grayer, maybe, maybe not. It might be because the pumice is harder in relation to this softer polished plate than it is to the new float glass. But the cerium oxide, which we're going to next, is going to take care of all this. So we're on to the last stage of the final polish, which is a felt wheel and cerium oxide. And the price of cerium oxide has gone through the roof because they use cerium oxide for catalytic converters for cars. So I don't know, last time I checked, I think this was like $30 a pound or something for this. It used to be a couple of bucks. The thing about it is, the better job you do, like on step 1 with grinding, step 2 with smoothing, and then step 3 with the cork, the better job you do as you go along, it's just that much easier and quicker and better for the next wheel. So this is the final one, so this is the end of the road. So if everything we've done up until now is, adequate or professional, whatever you want to call it, then this you could almost do blindfold. Same thing applies with this wheel. You don't keep it damp, and the glass will get hot and then it'll crack. I don't know, it's been, I don't even remember the last time I actually cracked a piece. I know that if you've got some trainee, they'll lose track of what they're doing and get the glass hot and crack. And if you're lucky, they'll tell you they cracked it, so you can plan accordingly. So this is actually a real true felt. They do make a synthetic wheel that simulates felt. And those aren't a bad idea because felt, if you leave the wheel moist and it's dark and not a lot of air movement, bacteria and mold and whatnot will attack the wheel, and then the felt is trash. So the thing about it is you want to like run the wheel for a little while when you're done to help dry it off, or put a fan on it. Sometimes if I'll shoot it with a little Lysol to make it so it won't get contaminated and get eaten up by a mold. And once again, like this is like an 8-inch wheel. I've got in storage a wheel that's like 28 inches in diameter and 4 inches wide, and it's huge. And it's great, but it's just, I don't want the commit the amount of space that is required to have it in your shop. So just yeah, these are looking nice. So this is the polished plate glass, okay, and you can see, at least I can see it. It's really pretty. It catches the light, and it's nice. It takes a nice polish. How to compare apples with apples here. Normally, I didn't do it, but normally I have this wheel running a little faster than that wheel. It's not a big deal either way. Okay, so let's put these together. I don't know, maybe. Well, you definitely can see the color difference. The machine bevel is totally pristine. I mean, this is done on a conveyor, and it's, you know, this business here is without any any flaws or any kind of variation. So that about winds it up for the beveling process, and yeah, maybe we'll do another one where we show some like surface decoration, like wheel engraving, a beaded bevel, a honeycomb bevel, different kinds of things. But for now, we're going to sign off. Thanks for watching.